Welcome to the project demonstration of temperature and moisture sensor for agriculture fertilization process. So here we are going to monitor the two parameters. One is the moisture content inside soil with the help of this soil moisture sensor, and temperature of the plant near the plants with the help of this LM35 temperature sensor. So based on the temperature and moisture content, we can suggest the fertilization for the plants. So here these two sensors interfaced to the PIC16F72 microcontroller. So at pin number A0 for the LM35 sensor, pin number A1 for the soil moisture sensor. So coming to the soil moisture sensor, so here these two electrodes provide the inputs to the microcontroller through this LM358 comparator along with operational amplifier. So here, so these two electrodes provide us the resistance between these two. So when we place this inside a soil, so it will check with the conductivity. If the moisture content is present, then the conductivity between these two electrodes will increases. So based on that increasing in conductivity, so we'll get the little bit voltage in millivolts. So that can't be understood directly by the microcontroller. For that purpose, we are going to converting that to the digital output, that is 0 volts or 5 volts. So based on the data, it will measure continuously by the microcontroller and it will display that in terms of percentage for the soil moisture content. And next, temperature in degrees centigrade, and that data will be displayed on 16:2 LCD screen, so which we have interfaced at pin number B2 to B7. So on this motherboard, we can observe the three major components. One is our microcontroller, which will taking care of inputs and outputs. Another is the crystal oscillator, which will provide us the 20 megahertz of clock frequency to the microcontroller. So the purpose of this crystal oscillator is, so we have provided the set of instructions in embedded C language. So each line need one pulse. So like that, controller can execute 20 mega instructions per second, as we are providing 20 mega pulses per second. So the third component is a reset switch to restart the microcontroller. Just it will restart the microcontroller, it won't erase the program which we have loaded inside the microcontroller. And the next is the whole system getting power supply from this transformer 230 volts AC input. So this 230 volts AC input step down by this 09 transformer, so which will take 230 volts AC inputs and provide us a 9 volts AC output. So to this regulated power supply board PCB. On this board, we can see the three stages. First is the rectifier to convert the AC to pulsating DC, and then to remove the pulses and to make the pulsating DC to smooth DC, we are making use of filter. So which will act as a filtration to remove the pulses. So we will get the smooth DC after this filter. So but we need 5 volts power supply, as the 5 volt is the operating voltage for the sensors, microcontrollers and LCD display. So to make the 9 volts DC as a 5 volts DC, we need to regulate that by using this 7805 regulator. So which will take greater than 5 volts and provide us the constant DC 5 volts output. So there is a LED indication which will show the status of this regulator power supply board working, and here is a LED indication will show the motherboard getting power supply, and this LED will show the status of program is executing. So when we on that, this particular light will on and off 2 times, and thereafter the welcome message will be displayed on the LCD screen. So let us see the demonstration. So welcome to the project, welcome message will be displayed on the LCD screen. So now the live temperature along with moisture content from the soil moisture sensor will be measured. So when I am placing this in a water content, so the conductivity between these two electrodes will increases. Based on the conductivity, we will get the percentage over here. So if you use the salt water, then you will get the more conductivity. Now as of now, we are using the mineral water, which has a less conductivity due to the minerals inside that. Okay, and coming to the temperature also, we can see the temperature is getting increased. So this is the part of a major project application. So based on these two sensors input, we can control the motors with the help of electromagnetic relay, and also we can get this data through IoT application that can be accessed from anywhere in the world. So these are the feature scope. We can add features to this project.